Hey, what is up, guys? Welcome to video number 3 of study sessions. I recorded one of these over the weekend, 4-hour long video, and the video spits out in my file system, and it's 10 minutes. So I'm like, okay. So I give up on it and knock out the graphing activity, the online homework, both of them, asking some questions on the forum, and the week 1 discussion. And I was just in the process of going through the textbook and preparing for the quiz that's due tonight. I actually just recorded an hour-long video 5 minutes ago, and I checked the file system again, and it gave me, I think it was again 10 minutes. Yeah, so I finally decided to not accept the lag and the mainly the cutting off of the video. So I lowered the quality settings. So I hope it's not too bad. I hope it's not unbearable. We'll see how bad of a lag it is, but hopefully the video does not cut out again. So I was just about to take a break because it was at like an hour or so. So I'll be right back, but looking forward to studying with you guys. Hey, what is up, guys? I am back. Just came back from a nice run and ready to go. I realized I should probably recap you on what we just did in the video Lost. So we left off here from video 2, how to represent circular motion. While I was doing this, I thought it was a great example of the argument, the debate of between, is pure math just useless versus applied math? And I think this is a great example because I imagine at one time this was pure math. Oh, this is just the study of circles, that's dumb. And then eventually it turns out that, modeling the function gives you sine and cosine, and they're probably still like, they probably still said, oh, that's useless, and then turns out a lot of things in nature you can model with sine and cosine waves. So just a cool example of that, I thought, as I was going through this. So it gives a little example of a Ferris wheel, just walks through it. To be honest, I still don't get one radius length and what that means, just radius length itself. Is it just a proportion? It's just not really sticking. Just talks about horizontal, the x and y, and then just gives in the unit circle. One thing was cool, I think it was here, about radius length, even if I don't get it yet, how you could have any radius, but if you wanted to find the x and y, I don't know, maybe you can without turning it into a unit circle of a radius of 1. Maybe you can find the x and y using sine and cosine. Cosine and sine. Maybe you can, but I thought it was cool how if you can't, you can just change it into a unit circle of 1 using 1 radius length, and you can kind of see they just divide it by what the radius is. You still need the radius, you just kind of convert it into the unit circle's pure form by dividing by the radius. So I thought that was cool. And then you can just turn it back once you found the x and y by rescaling it up. Yeah, and that just talks about the sine function. I don't get how they actually find the sine, like the actual output value. I tried in the video that's missing, doing like opposite over hypotenuse. And I was unclear, I forgot if it's sine of theta equals opposite over hypotenuse, so TOA. So I just tried theta equals opposite over hypotenuse and tried to find opposite because hypotenuse is obviously the radius. That didn't work. And so I think it is sine of theta equals opposite over hypotenuse. But then that leads me to like, how do you actually find sine? Like, how do they first find it? Before it was like in all these calculators and lookup tables. Anyway, so yeah. Sine of the angle is the y-coordinate, yada yada, boom, boom, boom. Then it just graphs it onto the horizontal. Thing I thought was interesting was it's nonlinear. You can kind of see it slows towards the top, still slows, and then goes fast. And opposite for cosine, and this can actually explain why cosine starts at 1, because its distance is 1, versus why sine starts at 0. So I thought that was cool. Okay, and here's where we left off. So again, this will be kind of quiet while I'm doing it, but then when I get to a good stopping point, I'll recap and hopefully make it interesting. And then due tonight we have the quiz. So Let's see. Yep. Hopefully this video doesn't cut out. It says 58 out of 58 FPS. CPU usage looks low. I don't see any errors like before. So, alright. 1.4 is 1.4 radians, which means the arc length is 1.4 times the radius of the, 1.4 divided by 6.8 is 1/4. 1.4 times 4 is 4. A little bit more. 1/5. 1 times 5. No, 2. Because it's 6.28. It's like 0.8 off. And then 4 times is 4, 16, 5.6. 5.6 a little closer. Just like 1/4 of the whole pi. That's actually, it's a bit more. No, it's a bit less. It's in between 1/4 and 1/5. Okay, yeah, so it's before the 90 degrees. And it's saying, what is the x distance from the origin, from the horizontal axis, vertical axis. Oh, yep, right before 90 degrees. 1.4 times. So it's about 0.17. What is cosine? Well, it's like, I can see it in my peripheral. What is this? What's the maximum distance? It's 1 radius length. You would just put in cosine 0 in radians. I would like another way to understand why any number, 2.5 x radians, is when multiplied by the circle's radius, the arc length. Apparently it's like you're multiplying by infinity, which is the radians, boom, 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 times the radius, and so like it's like all these rays. But I don't know, I'd want it. It just seems, that description seems far away as like a good explanation in this context where it says like subtended arc is 2.5 times as long as the circle's radius, even though it's, you know, the same thing. So let me know if you have any ideas or further explanations that would help me. Yeah. Actually, I'm going to try to, I think I already saw it, but whatever. And the general meaning for the value of cos. With 13 divided by 8, that means it's going to be over pi. You know, farther than pi. Is it farther than this one, though? Yes. It's going to be in the 4th quadrant. Because it's above 12 out of 8. Just barely. Past the 3rd pi over. It's barely past 3 pi over 2. And it means 13 pi over 8 times the radius is the arc length, meaning it's 13 pi over 8 times the radius length. It is 13 pi. Yeah, and whatever the answer is the horizontal distance from the vertical diameter. And it's positive because it's barely past. There we go. Okay. I don't know what's concavity. Okay, so it's going to graph it. So it's opposite of the sine, because initially sine increased fast and then decreased once it got around to pi over 2. This one increases slowly, and then increases fast, because this is where the horizontal distance really starts to move. Okay, so now we have drawn out. Yeah, sometimes I wonder if it's worth it to spend so much brain power on this basic stuff. Because I'm just impatient and want to get to the fun higher level stuff. And yes, I definitely didn't pay attention in lower level classes. But I wonder, just when you get to higher level, like I've heard you can like rederive this basic stuff using calculus, which is weird to me that you can kind of prove the lower stuff using an abstraction of it, but so sometimes I wonder if I'm like trying to make this foundation too strong and I'm just wasting time and that I should just jump forward, but I haven't had someone to speak with that can affirm or deny this, and so I'm just, yeah. Yeah. I've tried looking online, but no dice. Okay. Let's try to start at 1. It's a distance, and it's going to slowly decrease. And it's going to really speed up. It's going to keep going down. Yeah. It's really going to keep. And then it'll start to cave. I put that too close. And then it'll start to come up. It'll start to come up. Oops, slowly. And then fast. And it's really fast, around 3 pi over 2. And then it levels out around 2 pi. Okay. Wow. Congrats. We're done with module 7. Alright, I don't think I need to review that for you guys. Okay. Function notation. Luckily I got a review or teaching of it in the last pre-calc class, but there's still a lot I need to know. Here's the map. Oh, there's nothing, just review. What's the meaning of it means 5.2 is the input, and there's an output. And we'll just reiterate function equals input to output, and specifically an important criteria is that they're one output to every one input. Now there can be more than one inputs going to same output. So it would be helpful if I had the map example. But c'est la vie. Okay, so that's actually helpful. F x equals F is the name. This is the input. This is the output. This is the function definition. This is the rule. And I'll call it the function. box with a volume of 499 cubic inches is created when the length of the side of the square cutout is 2.9 inches. Volume of the cube. How can you represent this using function notation? Well, it doesn't match up with this graph, but yeah. That would be the describe what f x plus 1 minus f. Okay, it means the input plus 1 or horizontal shift to the right. To the left. And then whatever that output is minus the result of just a regular function of x, the output of x. Difference in volume between the box form. Oh. Yeah, I should have given it in context. Difference in volume between the box form and the box form. Oh, that's interesting. This general form, like the difference of function, can help you, that's interesting, really solidify what the rate of change is for any function. Because it doesn't have to be this box thing, it could be, yeah. It's interesting. F x plus 1 minus f x equals a good function to find the rate of change. Rate of change. Is y output squared by 3 times. It means when the box cutout length is 0.75, whatever the output is, the cube, the volume, multiply that times 3, as if there's 3 boxes. I've actually been finding this interesting, chaining together functions. It just seems really powerful. E equals FD. So it's distance divided by 3. So you have 32 miles per gallon. And then multiply times the x. Now suppose you want to create a limit. So it's just your composite. So you just do like that separate one. It's just f of x equals x over 32, and then it's g of f of x. Okay, so it's just x minus 32 goes into g of x, which is just x times 3.19. So x over 32 in parentheses times 3.19. Then check it up here. Yeah, he just does these. This is, yeah. Okay. Here, right here. There we go. I don't know why that would be helpful, replacing it with k. Okay. You got 3x plus 1 squared. Minus 5x plus 1 plus 1. Okay, so alright. FOIL out. So we got 3x plus 1. X plus 1. What's this? Minus 5x minus 5 plus 1. Minus 5x minus 4. Yes. Okay. X squared plus x plus 1. Multiply that by 3, 3x squared That's 2x 6 plus 6x plus 3 minus 5x minus 4. 3x squared plus 6x minus 5x minus 1. And then we got 3x squared plus x minus 1. 3x squared plus x minus 1. Okay. F of x equals find f of g of x, where g is some other function. Its usefulness. Area and time. If you have a situation where you have no formula to directly relate them, but where you do have a formula that relates area and radius in another. Oh, that's cool. So it's like a bridge. So A equals B, B equals C, kind of thing. That's really cool. Does that mean you are creating the formula that relates them then? So, I hope that's correct. I'm going to write that down. A equals B equals C. Area and time. And eventually, no formula. Area and radius. Radius and time. Right now it's okay. A equals B. Let's say A is area. Let's say C. It's time, area and time. It's area and radius. Okay, you want half. Yeah, it's like a bridge. So R is the B. So the input is area. You get out radius. Get out radius. Input radius. Get out time. Cool. Yeah, so it's like an A equals B equals C thing. Maybe it'd be more like an arrow. I'll write it down again. Even though we went over this last course. Wonder if order matters. Like, I think so. Let's say there's something in the domain of f of x that isn't in the domain of g of x. Would that be in the domain of h of x? No, because okay. So it is order dependent. Should okay, ripple. Square meters. I misspelled the context. you have speed. Here's this example that says area, radius, and time. You kind of have time. You have speed, which is distance over time. But okay, you have oh, it doesn't give you the just give you the radius, does it? Also, how can you represent a circle's area in square meters? That makes me think square. This is cool. Okay, let's go read it. I'll read it. Mine was 2 pi r squared. Why is it radius times 2? I might put that down. Y is area of... So 2 pi times the radius is the circumference, I think. Circumference is 2 pi times radius. That's their circumference. That's just the outside, it's not everything inside. So why does r squared and also decreasing pi by a half then get you everything inside? Why is area? I could just say, let's derive pi r squared. But anyway, where area equals h of r. Okay, so A equals area, A equals h of r, h of r equals pi. Okay, pi radius probably does that for each second passes. The radius of the circle increases. Representing radius r. It's a function of time t. This relationship can be expressed as gt equals 0.7t, where r equals gt. Okay, got it? Change count. Yes. Increases by 0.7 meters every second. Gt t equals time equals 0.7t. Gt equals radius at a time. Since the output of the first formula, gt, is a radius r, and the input of the second formula is r, we can relate time and area by composing these two functions. Okay, let's see if I can... Okay, what do we want? We want, in terms of time, express the area in terms of time. Right now you just have by the radius. GT is the radius. Oh, okay. Okay, have h of r go to h of GT. Because GT is radius as the output. So writing it out, it would be 0.7t squared times pi. Damn, that's dope. I don't know why this really makes me want to have enough room to have like a little kiddie pool, make my own little boat, like with little wood and a little sail with paper, and like just blow it, like, and then see how, I don't know why. This problem is really making me want to do that. That's, okay. Pi times 0.17. This is relating, what's the area? You have the area in terms of t, time. Yeah. Okay. Let's see. Okay, so it's simplified, but I will fucking take it. Nice. This is really cool. Because like when I've never seen that before, relating time and area. But now I think about it, like that probably happens a lot. Maybe you're in a car factory. You're testing a new vehicle. So you know how they like blow it up and like run it into shit, and they like film it at high speeds, and they see like where the parts go, if the fake human in the vehicle is safe. Granted, I imagine there's a lot more, but like the very idea of it, like, you know, what's the max what's the max area that the like any part of the car flies off, you know? Because maybe if it's a mile away, that's like, you know, that's a dangerous car, because then it could just kill somebody like a mile away. Just this little windshield wiper like kill someone. And so that would be an example. And so like you'd have the video frame, and then relating to time. Oh, at this second, what's the area that's been consumed or like maximally penetrated by the car parts. That'd be one example. That's dope. That's dope. Determine the volume of a sphere after its radius has increased 2 inches per minute for 3 minutes. Assume that the volume is 0 when the increase starts. We begin by letting t equals time in seconds. As the volume starts to increase, f of t equals the length of the radius equals the volume of the sphere in cubic inches for a radius length of r inches. Okay, so it's just, yeah, we can call that the formula for the volume. I know we're all. Sphere volume is 4/3 pi r cubed, which we will call the function g. So g of r. Also, we'll ask, why is this the case? Okay, I got this. So we just put f of t into g, and f of t equals r. Okay, so I can just plug in the exact values, but why don't I just get the general case? Okay, so g f of t. Yes. Okay. And this is, you start with the f of t, which is, maybe it wants me to make it 2 inches per minute. So it's giving me the speed. So it's 2x, or 2t. And 3 minutes is the input value. Okay, we got 2x, or 2t. 2 inches per minute. Yeah, so if it's 0, it's 0. If it's 1, it's 2 inches. Okay, yeah. Okay, you got that. Now you put it into G, which is 4/3 times pi. Okay, times this, but you have to cube this. Okay. That's the general case. I feel like you can. Yeah. You just say 4 pi over 3 times. But, okay. Now just plug in 3. So, okay, so G of f of 3 equals 4/3 times pi times 2, 3 cubed. So 6 cubed. Okay. Oh, you know what? No fucking way. This is not. I just realized this is not laggy at all. I thought it would when it popped out, but that was weird because I tried this last night, like going down to the lowest setting, or a few nights ago, and I tried going down to like 10 FPS. Right now it's 48, and it was still laggy. So I was like, oh, just fuck it, I'll just do the highest value. But now it's working, so I apologize it took me this long to get here, but hopefully it's a good quality video for you guys. Okay. Fourth. Give me the calculator. Okay, it's a little slow. Okay, we got 4/3 times pi times 6 cubed. 4/3 times pi times 2 times 3 is 6 cubed. 904. Okay. Equals 904.77. And Lord forbid I miss the units. Cubic inches. Okay. Uh-oh. Oh yeah, I saw the 288 and I was worried. Okay. Okay, they simplified, but yeah, that's what okay. That's cool. That's really cool, actually. Let's see if I can. A gardener is designing a rectangular planter or a rose garden in front of the administration building on the university campus. Gardener has enough material to build a 300-foot fence to enclose the garden. We also have enough roses to fill a 1,000 square foot planter. Write a function to represent the area of the rose garden in terms of the length of the side of the garden. Assume that we will use all of the fencing. This was similar to one of the homework problems, but I'll be honest, I had some trouble with it. That's enough material. So you're saying square foot. So you're saying the area is 5,200, and the is that what it's called? Perimeter? Yeah, perimeter is 300. Okay, so let's see, if I didn't see this and work through it in the homework, I wouldn't immediately know how to like connect these two. But it's the same idea of connecting equations. So you have perimeter equals 300, and that's just the length of the thing outside, feet. And then you have max area, 5,200 square feet. Okay, so write a function to represent the area in terms of the length. Okay, so perimeter is 300, but in general, it is 2L plus 2 width. And area equals length times width. And let's see, I'm trying to find you need to get L alone. I think it. Okay. I need to get L alone. So P equals 2L plus 2W, just minus 2W minus 2W. 2L equals P minus 2W, divided by 2, divided by 2. L equals P minus 2W over 2, all over 2. Now you don't have length, you do have perimeter, but you don't have width. And I don't think it's true for all rectangles that width is just length divided by 2. So I don't know how I would solve just with this equation I just have. But now I have area. So now I've found length from perimeter and width. And now I'm going to work on the area equation and just say I want L alone, so let's divide by width. So L equals area divided by width. I think you're going to set them equal. Since both are L, then you set them both. So I'll put A over W on one side and P minus 2W minus 2 on the other side. Times 2. So you got 2A over W. What am I looking for? Oh. Actually, yeah, that's not, I should, I want area in terms of length. Oh, I fucked this up. There should only be L's in the equation. Okay, we were at that cross. We were at that equation equal to equation step. let's just get rid of W and get A by itself. So now we have A equals, this is a weird thing, P minus 2W over 2 parentheses W. How do I represent width as just length? But now that I've combined them, I'm pretty sure I could solve for W. Yeah, actually, what? Oh, I set my L's, so I got rid of L. I would be solving for W in this case, which I... Interesting. Oh, so maybe I want to just get both of these to be W. That's like, yeah, you know what, let's try to go back. So area equals length times width. Just get width alone, so divide by L, divide by L. So A divided by L equals W, and for the other one, it's P equals 2L plus 2W minus 2L minus 2L. Okay, so 2W equals P minus 2L. Divide by 2, divide by 2. Okay, W equals P minus 2L over 2. Now you can set the W's equal A over L equals P minus 2L over 2. Okay, yeah. Okay, yeah. So L, let's get A on its own. A equals P minus 2L over 2. Keep the L. Okay. Area equals P minus 2L over 2, all times L. And I have perimeter, and I have area, so I can solve for L now. So area is 5,200 equals 300 minus 2L over 2 times L. Okay, let's move L back. Yeah, so 5,200L equals 300 minus 2L over 2. Multiply this by 2, multiply by 2, 5,200, 10,400. L equals 300 minus 2L plus 2L plus 2L plus 2L. I don't think I can, yeah, okay, so 10,400L plus 2L equals 300. What am I doing? How am I supposed to get? Oh. Minus 300. Minus 300. Okay. 10,400L minus 300 equals 2L. Could just divide by 2. What the? No. Can I do that? Can I just... If you have like if you have 2x, 2 times x, and you have like 1x on the other side, can you just... Yeah, you can. Okay. Okay, that's weird. Minus 2l, minus 2l, 10,398 L. Minus 300 equals 0. Plus, I don't know why this took so long. Plus 300, 10, 398 L equals 300. Divided by 10,098, 10,398. Okay. 300 divided by 10,398. What the hell is going on? This is not looking correct. L equals 0.0288. This is not looking correct. Okay, let's give it a read. I could go back to that width version, but I'm good. What is the length and width of the rectangle can take on different meaning to define variables. It's part of the card and the perimeter of the rectangle. That follows that 300 equals 2L. Since we need to express the area in terms of the length, we can use the above to write W in terms of L. Solving this equation for W gives minus 2L minus 2, 150 minus L equals W. W in terms of L. Since the formula for the area of the rectangle is length times width, we can define a function to represent the area of the garden in terms of L by... Got it. Well, there we go. Okay. Solution. P equals 2L plus 2W. 300 equals 2L plus 2W minus 2L plus 2L. 300 minus 2L. 2W divided by 2. 150 minus L equals W. Area equals L times width. So area equals L times 150 minus L. Distribute in. A equals 150L minus L squared. Okay. Oh, okay. I'm gonna take a quick break. Okie dokie. I am back. Let's dive back into it. Okay, so I'll be honest, I just finished a whole course, previous Pre-Calc 1 on doing this. Okay, this one might be given. I'm going to avoid just the composite functions. I know how to do that. And I know how to show if they're inverse or not. So let's try this B given. And that the surface area is a function function of. Okay, that's a good one. Okay. Create a function that expresses the surface area of the cube as a function of the volume V of the cube. Okay, we have surface area A equals 6 times S. I feel like it's just volume equals S cubed. Okay, so let's write that out. S equals cube root V area equals 6 times surface area squared. Okay, create a function that expresses the surface area. So A, in terms of the volume of V, is a function of the volume of B. Actually, I don't have to. No. S is the surface. Yeah, so actually it's just 6 times cube root of V squared. Yeah. And you could write it as let's call it S of V, and then A of S. It's obviously just A of S of V. Okay. Let's see if we got that one. 6 times. Okay. Nice. Use the graph below. Evaluate. Oh, almost done. I read that answer. Evaluate F. So G of 2, using input and output language, describe reasoning. Well, which one's, okay, the top one's G. Okay, input 2 means the output is 4. Evaluate F. So you have G of 2. G of 2 is output's 4. Now you plug F, X, the X value for F as 4. So 4, and you get 3. Okay. Function maps. Okay, okay. Didn't read that one. That's good. Functions F and G are defined based on the table. Answer the following questions. F of 2. F of 2 is just -8. F of G of 2. So G of 2 is -1. -1 is the input for F of X is 6. So I got 6. Oh, I read that answer, but G of 1 is it's -3. And then plug it back in. G of -3 is 3. So the answer is 3. Okay. And look at that. Nice job, guys. I can only imagine what it's like following along this beautiful work of art. This beautiful study session that I'm sure you're enjoying. I can't wait to do more fun stuff with you guys, like coding or building some models or agent chaining together. That'd be fun. But we gotta build the foundation. function rules define how an input is related to an output. Oh, that's cool. Examine mechanisms for reversing the function process to map output quantities to the original input quantities. Use functions like also subsets together. Good job here. Possible on the model. This is nice that they relate it to the real world. Makes it more solid. Nice on that. Is this relationship a function? Yes. just went over this in my last class. Yeah, this is a function. It's fine. It just, there can't be one input going to two outputs. No, because 6 is going to 2. No. My last class gave a good rule of thumb. If you can draw a line downwards through the graph and hit multiple points, then it's not a function. Because that would mean that one x, vertical line, is outputting multiple y's, which, it also needs formula from the length and width of the box in terms of the length of the cycle. So volume, okay. Step 1. What quantities in this situation stay fixed? I don't know what, it asked me this too, I think on a workbook problem. Is it saying, over all possible inputs that give any output of a volume, what, are you talking about in that scenario? What stays fixed is that you have an 8.5 by 11, but you can vary the side length cut, and thus the volume can also be varied. Now, and also width and length can be varied. So I'm going to say just the initial paper. Oh, okay. What quantities are to be related in this situation? What quantities vary as the input? Okay, I remember this from trying it out. Are to be related. Well, height of the box is equal to the length cut. I don't remember. No, yeah, it's the length and the width of the box has a relation. It's to the length cut. I think it's 2 times the length cut. Either the length, the original length, so 11, minus 2 times the length cut, since you're cutting it on 2 sides. Or if you're measuring the width, 8.5 minus 2 times the length cut. Okay, what else? The volume obviously depends, is related to the, length, width, volume. Okay. Yeah, okay, about that. Yes. I don't know how someone's supposed to notice without actually doing it. Oh, that's helpful. How do the quantities, the length of the side of the cutout and width of the box change together? 8.5 minus 2 times the length of the side of the cutout. Okay. Oh, how do the length of the side of the cutout and the length of the box? The length is just 11 minus 2 times the side. Going by this one, as x increases, L decreases. Oh, one of the domain matters that the length of the side of the cutout x can assume. Okay, well, if it's 11 minus 2x, x being one of the side of the cutouts, this cannot be greater, well, how do you put it? This part has to be greater than 0, yeah. Now let's solve for x. Pretty sure that's, yeah, plus 2x, yeah. 11, 2x, minus divided by 2, divided by 2. X must be less than 5.5, which makes sense because we get. And what else? I feel like it's on the other side too. X cannot be, and well, x can't be 0 itself. So x has to be between, it's greater than, or no, not or just greater than 0. And it also can't be 5.5 exactly, so. Okay, that's the domain value, 0 to 5.5. Oh, shit. I only did it for, yeah, it's right. I only did it for 11, not than 8.5. How do the length of the side of the cutout and the volume of the box covary? That's a good question. So I know that, what is it? Length equals 11 minus 2x. I know that width is 8.5 minus 2x. Area is, volume, and I know height is x. Area is just length times width times height. Put them together, 11 minus 2x, 8.5 minus 2x, and then x. Pretty sure I just FOIL 1, 2, 2. What's that? 5.5. 88. No, 88 plus 5.5. 93.5. Okay. Minus 22x. Plus 17. Minus 17. X. Plus 4x squared. I feel like there should be a, oh, yeah. Okay. Now let's plus negative. Okay, so we have 4x squared minus 39x plus 93.5. Okay, now all of that is multiplied by x. Distribute that in. We have 4x cubed minus 39x squared plus 93.5x. Okay. So you could say, how do the length of the side of the cutout and the volume of, well, cube this is There's no horizontal shift. So its origin might be at 0. And then and since x cannot be 0 or less, it won't have this part. So it's just like this. I feel like I've seen it though, like when I graphed it previously, when I was doing the box cutout, I think it was for the workbook, I had to graph it. Mine was like, and then there was a local maximum, and then it went down to negative, and then it went to infinity. And yeah, and then you can say cubically, as x increases, see, because if it's like the one I drew, I can't simply say as x increases, the volume increases, because there was a point where it actually started to decrease. Now, if it's not like that, and it's just a simple cube, parent function, then I could say, you know, as the length of the side increases, volume increases. Okay, let's see what it says. As the length of the side, the volume initially increases from 0 cubic inches to some maximum value. Well, as the length of the side of the outcome continues to decrease to... I hope it doesn't put it as quadratic. That's sounding like quadratic. But I just multiplied it out. I obviously got a cube. Right there, h is x. Yep, now combine it. Okay, that's what I got. Verify. Okay. What? What? What is going on here? Oh shit. What? Maybe I expanded it out wrong. Why is... I'm getting a cube polynomial. Yeah, look at that. Does that... That's not what they showed me. Actually, I think I asked this in my discussion thing. Yeah, look at that. Look what they're showing me. and I didn't even do... Okay, let's test this out. I'm going to write out my expanded version. It's looking close. Look at that. Match. You know, maybe I'll put equals 28. Even worse. Hey guys. Ooh. Okay. Okie dokie. So you put this whole thing is 2.3. Oh, because x is. Cool. That's cool. That's cool. The x value is the cutout size, which is x, and y is the width. .3 is the width. Okay, that's cool. I wonder what x would look like. X equals W minus I think it's gonna. Doesn't run exactly through it. Let's do 8.5 minus 2x. y equals 2.3. One, 2.3, 3.1, 2.3. Now, what would this one tell you? This is giving you x in terms of w. Wait, the original one gives you w in terms of x. So width in terms of x. This gives you x in terms of w. So if your width was 2.3, your box cutout would be 6.55, even though we can't go that high. Now, let's do like one we would know. If your width was this is saying, oh, okay. If your width was, this is weird. If your width was, I'm gonna ask a question. I don't really. Oh, huh. By the way, oh, 7.6. I didn't read that. 7.6. That corresponds to a box length of 7.6. So in this case, x would be 7.6. Or, oh yeah, 7.6. Seems wrong. This is saying a box length. I don't know, why is the width? This is asking, what is the length that corresponds to a box length? 7.6 box length. Oh, I've been saying this is width. Yeah, it is. The value of the cutouts. Write a formula. Yeah, this is. I put w minus 8.5 over minus 2. says box length, and we're still talking about width. I feel like that's the mistake. They're known to make it. Box width at 7.6. Why 7.6? So this does not make any fucking 7. Okay, let's see what they have to say. We know that the length of the box. So we need to substitute 7.6 L and solve for the 1.7. So a square. Let's find the solution by graphing the lines L equals. Yeah, then. Makes sense. Where it's possible to isolate the output volume, we can write a new formula that accepts value of the original output quality, length of the box, and determines values of the original. What about functions where there's more than one input that goes to one output? Like square roots. Well, granted, I did skip over a bit, but I feel like what it promised about the invert, like the going backwards. I mean, I guess this is going backwards, but I feel like I could have used another example. Yeah. Yeah. We write statements like v equals f of x when we want to convey a relationship such as volume v is a function of the length of the square function of x. The parentheses around x do not indicate that f see any advantages to giving a function a name. Clarity, you can put one inside the other. Once the function is defined, you can simply say f. So you don't say f of x, you say f to refer to the relationship established between once a function rule, parentheses, definition is established. relationship between volume and cutout length. Represent functions. Okay. Oh, what the? Oh, that's it. The first item. Oh. Nice. Not too shabby. I feel like I'm reaching my limit though. I don't know if I'm gonna have enough. I just won't absorb it, module 2, but let's see what it is. And then we'll just, we'll get that quiz out of the way. 19 pages. I feel like actually this is good, more of the practice between, yeah. Oh, yeah, this is cool. So I remember 3 blue, 1 browns example of calculus was having to do with speed and distance. So this would be cool if the calc professor that I take does the same example. This would be really cool to get knowledge of. Okay, I hope this is allowed. I was thinking of this, that I can take the quiz with you guys. Let's see, what's on my... Okay, let's... I want to see... I honestly forgot if I'm... what resources I'm allowed for quizzes. Oh, screen black. Okay, how much are quizzes worth? Okay, good to know. Less than most. I feel like he said it's open book. So I don't even... Okay. You may use any class materials, but please do your own work. Refer to the academic. Uploading, quizzes are scheduled. Open exam. Okay, so yeah, it says class materials. So got like a little cheat sheet of formulas. I didn't put a sphere area. Or, what was it, square or cube. Surface area, but I feel like I'm showing. Okay. Got these notes. Actually, the homework was really annoying. It was by this shitty, well, you'll see. And they were so picky for the answers, like, really picky. And it didn't give any feedback, that it was just like a minor, it wasn't even a minor mistake, it was just a different way of representing it. It didn't like it. You know, let's review the open forum, see what people have said. Also, there should be, oh, it's the same. Okay, let's see what people got. That's my 2-hour recording. Okay. God bless. God bless. Just absolutely bombed. Be sure to study Module 7 from the learning materials. All the quizzes, all circles and trig. On a graphing activity, I only let that sound. Okay, let's see what people said. And second prompt. I did have some issues with that. Click on one of the circles on the graph. Okay. Okay, so we got that. I wonder if I was got an answer. Oh. What? He says he said to post it. He said to really prioritize the Q&A discussion as a medium. If you see one of the, we've been over, we see one of the prior videos. He does he works through the problems, and he's obviously a very intelligent professor. But the course infrastructure is just horrible. Sorry, I mean, it sounds like when he's told us that the history used to be all connected at work, and now it's like, holy fuck, this guy, dude, we understand. This guy's so, I. Holy fuck, dude, why didn't you say that the reason? See, so you know. What's today? Tuesday? Today's. Oh, his office hours are tomorrow. I'm gonna go. All right. No, fuck it. Hey, what that guy? That guy said module 7. This is week 2. Oh, this is the homework. And we did the learning materials of 7. Oh, actually, it's ready to go. Yeah, that was the first thing we did. Alright, that guy's saying learning materials. He said from learning materials, not the homework. I don't know why I cannot get over. I kind of want to prepare for a March meeting with him. Just kind of not get over. Yeah, I feel like this would be accessed through that online portal, and it would provide answers for these, or at least the explanations. Okay. It says course materials, so I could just access the module. Hell, I could access next week's homework too, which is on module 7. 5 points, maybe 5 questions, even if I had to access the homework. YOLO. Oh shit. Yeah, it asked me this in the question. Oh, I just realized they don't let me have 2 of these open. Suppose 2 adjacent. I've answered this in the homework, or located it in the coordinate axis. This is attempt 1 of 2. Okay. What is the length of the side of the square? To adjacent. Okay. Pretty sure it's just distance formula. Where was this? This was here, if I'm not mistaken. I mean, it lets me open 2 instances of the homework. Oh, nice. Okay. What was it? It was, oh, here we go. Rotated square is placed on a coordinate plane in 2 adjacent corners of the square. I had quiz work for this. Okay, what did I? Okay. This is homework 3.1. No, this was before this. This is the notes. Might be too far. Week 1. This was due. This was due the 29th. So it would have been before. Well, shit. I cannot spend this long on. Okay, let's see. I feel like it was down. Distance formula. This was all functions. Where was that? This was not it. I've seen this before. Maybe I should have done. Let's see if this is here. Oh. Oh. Should have done this. Oops. Distance between two locations on any grid. Okay, so just do them. Okay. Actually, maybe there's some example questions. Okay. Yeah, so we have that. It's just distance formula. Which is, okay, so x1 minus x2 squared plus y1 minus y2 squared equals r squared. R squared being the distance. Okay. Oh. Okay. Let's get calculator going. Sorry guys. I'm gonna need this in different, just so I can go quick. Let's do math away. So x1 is minus 4, so minus 4, minus 4, minus 4, squared plus minus 7 minus minus 3 squared equals x squared. Yeah, then just find x. Okay, that's the distance. It's gonna be two values. 8 or negative 8. I suppose 2 adjacent. Pretty sure adjacent. That doesn't tell me whether it's length or width, though. Oh, a square is the same. It's not a rectangle. What is the length of the side of a square? Well, a negative length doesn't make sense. Okay, so 4 square root 5. 8.9. Okay, yeah. What is the area of the square? See, this is where I feel like it's going to mark me even if I do it right. Maybe 4. I'll just put 4 square root 5. And then times 2. Or, not times 2. Square. Oh, see? Oh. There it is. You can't have more than one. Oh, okay. This is not my quiz, big dog. Fuck. Oh, fuck me. Okay, well, I'm not gonna do that again. Oh. Okay. Come on. Oh wait, restarts it. Oh fuck, I gotta fucking go. Oh boy. Okay. 4 square root 5. 4 square root 5. Oh, Jesus, this one. Oh, God bless. God bless. Okay, how do I... Okay, suppose a circle is centered at the vertex. At which point... Oh, I got this. Coordinate equal to 1. You just... same thing, distance formula. 0. Which... X equal to 1. So minus 1. For which point is the x coordinate equal to 1? Yeah, squared plus 0 minus y2 squared equals 5 squared. Should give me 2 values. Your first answer should have a positive y value. Okay, got it. Okay, same thing, just pop it in the algebra calculator. 0 minus 1 squared plus 0 minus y squared equals 5 squared. Okay, and then solve for y. Yeah, okay, it says your first answer should be the positive. So I got 2. Okay. 2 square root 6. Invalid notation. God bless. Yeah, what's wrong? What's wrong with this? Does it want the Oh. Yeah. This is 1, comma. Yeah. Which points? And 4 point. Yep. Okay. X coordinate equal to 1. Okay, now the other one. 1. Negative. Did that right? Negative 2 square root 6. Okay. 1. 1. Yeah. First answer. Okay. For which points the circle is the x coordinate equal to 4? Just pop in 4 again. Copy. Paste. Okay, it's minus 4 plus 0 minus y. For which points on the is the x coordinate? Okay. That's fine. Okay. Minus 3, 3. Okay, so we got 4, 3, and then we got 4 minus 3. 1x. Wait. Oh yeah, because this. Okay. What is the equation of the graph rule? I don't know how much it wants. It's okay. It's 0 minus x squared plus 0 minus y squared equals 5 squared. This signifies the vertex. This gives the circle its infinite thing. This gives it a placement. Oh, daddy. Daddy. Set every circle is okay. Point. What is the radius of the circle? Oh, okay. I'm just gonna copy this. Same thing, and now you're just solving for r. Okay, it's 1, 1. So 1 for x1, and then y1, just 1. And for x2, you have minus 4. And then for y2, you have 5. Now you're just solving for x squared. What is the radius? What is the equation for the graph of the circle? 41. Wait. 41, square root of 41, and negative square root of 41. I think that's fine. Let's graph it and see that. I have 2 tries. Never seen a radius be. Oh, 40. Okay. Square root of 40. Yeah, let's put that. Oh. Square root of 41. Explain. Yeah, okay. What is the equation for the graph of the circle? Let's see. It's 1 minus x squared plus 1 minus y squared equals 41 squared. Because I asked for x. Oh, no. Square root of 41 squared. I could just say 41, I feel like. But it didn't like that square notation. I swear, on the homework, it was like writing that shit wrong when I put it, I put it like that. Okay. Damn, poor guy that kind of bombed that shit on this. He probably didn't know it was open though. Side areas open. Cut on 4 equally sized squares from the corners of a. So instead of 8.5 by 11, it's this. Write a formula. Oh shit, it gives the volume of the resulting box in cubic centimeters in terms of x, the varying length of a square. Okay. I feel like it's fundamentally the same. Okay, you have volume, volume equals length times width times height. Length, okay, length 8.5 by 11. That's width times height. 8.5 by 11 means width, length. Okay, so length is actually 32. Okay, width equals 20. Okay, but length equals, in relation to x, it's 32 minus 2x. Okay. Width is 20 minus 2x. Height is just x. You know, I'm going to ask about that in office hours. I'm going to ask about that quadratic graph in that workbook. Versus I'm getting cubic graph. Okay, to here. Volume of resulting box in centimeters times x. Varying length. Okay, we just combine them. So v equals 32 minus 2x, close parentheses, 20 minus 2x, second parentheses, and then x. 32 minus 2x, 20 minus 2x, x. There's a graph, actually, use a graphing calculator to graph this formula with v on the vertical axis and x on the horizontal axis. Use your brackets. What is the maximum volume of the box? I don't have a graphing calculator, but I feel like I can use Desmos. Yeah, okay, let's clear these. Okay, so f of x equals 32 minus 2x, 20 minus 2x, x. Okay, this is a very large. Where does this go? That's until over 1,000. What is the maximum volume of the box? Well, it says here that it goes till infinity, and there's also a local maximum, so. And you had a quadratic in your resources. Should have gone to office hours yesterday. the maximum volume of the box? Oh, maybe put a domain on it. 16 when you start to go up. Yeah. This is 10. Oh, 16 would be 16. I still have one more question. Yeah, let's say this one. I feel like I've done this before. 1152. What's the side length in a square cutout that achieves the maximum volume? It's 4. BI. Does that make sense? Find the volume of the box when the square cutout side length is 2. Oh, right. Oh. 2, 8, 9, 6. Oh, I was actually worried about that one. Oof. Okay. Different numbers. Find the side length of a cutout that will achieve a volume of 300 centimeters. Okay, so it's just V equals 30 minus 2x. It's the same thing. And now it's 20, so 20 is remaining the same. I'm just going to change one tiny thing, huh? Okay. Okay, so if I just graph it, I just have to change one thing. 30. 30 minus 2. Width times length. Side. I want you to have a volume of 300. There's 3 answers. Yeah, it's never asked me about that third line up. Okay. Oh, you know what? It might ask. Might want the square root for exact. Oh, I can just maybe I can put 300. Oh no, that changed the graph. Wait, I feel like I can. I feel like I can put this into math way. Okay, 300 equals. Whatever it is, I said. 30 minus 2x. 20 minus 2x. X. Solve for x. Gave me 3 answers. Oh, gave me approximates too. Didn't even. Okay, so maybe there's no. So we got 0.5, 8, and 15. Yeah, 0.5, 8. Okay. What do we got? Okay, so it's an approximate. Oh no. I'm just gonna write 0.54915B41. Then the next biggest 8.6353939. Oh, please count this. 13.8. 1544849. Oh, I had this yellow before. Fuck you, man. What's wrong here? Oh, is one of them negative? No. It's definitely it's definitely just something. Oh, okay. Well, I have the time. I wonder, I'll just do it by hand, maybe. Solve. I don't know how to get 3, actually. Did I put a period there? No. I bet it's put a 0 here. It'd be like that. That was it. Okay, I can't just rely on that. There's only one more chance. What if it marks it wrong? Okay, what can I do? I have the equation. It already solved for me. Damn, I wonder how maybe just look at another calculator to get a more exact answer. Actually, no, just put it in again. Solve using the quadratic. No, find the roots. Don't think. Evaluate. More. Solve the rational equation for x. Gave me the same thing. Oh, I wonder how I can. Yeah, you know what, maybe. Okay. The zero product property says this is equal to 0, and you can set each of them equal to 0. I don't think that holds for v being 300. Maybe I just simplify this. Yeah, I got this. So much work. Set to 300, simplify, and find them. Okay. Fuck. Actually, I wonder if this can simplify it. Oh. Right in standard form. Okay. Yes, please. Oh, okay. Let's not include. It says plus 300. Got that. Okay, let's just write this in standard form. Write in standard form. Is it the same for? Okay. So we got v equals 4x cubed minus 100x squared plus 600x. Now what do I do? That's set to 300. I could just set it all to 0. So I'd have 4x 3 minus 100x squared minus 6 plus 600x minus 300 equals 0. I don't know how to solve cube. Okay, let's... minus 100x squared plus 600x minus 300 equals 0. Solve for, find all complex solutions. Graph more. Solve the inequality, find all complex. Find that solve by being the square. I know. Let's solve for x. Yeah, it still gave me the approximate. Well, I should care about my grade. 0.8, but it's only 10%. What's that? 4.8 out of 5. Oh, it's a 9. Oh, fuck me. I don't care. I don't give a fuck. Yeah, fuck it. Yeah, I wonder what it was. It's not gonna tell me the right answer. Shit, what's this software? What? Dude, what? What? What's this? Wait, is it? Oh, well, okay. Well, 4 out of 5 is not 96. Oh, okay, I did count it. I was like, I thought it didn't count that extra 0.8. Okay. Thanks a lot, guys. Appreciate your help. Good job. Yeah, I think we're good. Peace, guys.